Hey, hello. I'm Krishnavardhan as your tutor for the lecture series on the Internet of Things. This lecture series is brought to you by ZDAP Technologies. Before starting our first lecture, let us discuss what exactly we are going to learn. I will make sure that you have bags of knowledge in your mind by the end of the lecture series. Why wait? Let's move. Course content. In the first lecture, we will understand what is IoT and what role does this play in the near future and much more. In the second lecture, we will go through an interesting topic. How does it work? It's quite interesting. In the third lecture, we will understand the components of IoT. Please note that this lecture does not teach you the real hand use components. We have a separate lecture for that. In this lecture, we will understand what are the software components and the building components used in IoT. In the fourth lecture, which is applications and careers, I'll brief you on where is the IoT used in real life applications, and also I'll brief you on the career and its growth in the IoT. In the fifth lecture, which is the database and wireless communication, we will understand what are the databases, and also I will show you how few data centers look alike. The interesting part of this is that even you can make your own data center at your home, one for yourself. But there are quite many disadvantages. I'll tell you what they are. And in the lecture 6, we will learn about the actual sensing and actuation. This is going to be really interesting. And in the 7th lecture, we will learn about the machine-to-machine communication. Again, the engaging part of this lecture is the M2M communication, also called as machine-to-machine communication. There is no need for human interface. We will understand it how. In the lecture 8, we will have brief about the network connectivity. This is something really important. In the lecture 9, I'll make you understand the Arduino IDE with a source code. This is really important for all the IoTians. And in the lecture 10, introduction to microcontrollers. We will brief about the microcontrollers. Please note that we are not going to discuss the whole microcontrollers, since that is another subject. We'll be going through only the necessary part of it. In the 11th lecture, which is Introduction to Arduino, Node MCU and RPI, also called as Raspberry Pi, we will understand the working operation and mounting components that are placed on the microcontrollers that we use in IoT. Okay, aren't you feeling the same that we are moving to the practical sessions very soon? Yes, we do. So, in the lecture 12, we will understand the differences in the Arduino, Node MCU and Raspberry Pi, RPI. Okay. In the lecture 13, this is my favorite topic, mediators. It is very simple and useful to understand. Everyone who are learning IoT or also who are making much more projects in IoT will have to go through this. Okay, mediators is something a third party or third party who is going to help to transfer the data from one form to another. So, we'll briefly understand what exactly they are. Okay. Next, in the lecture 14, we will understand the breadboard and its connections, and the PCB board also. See, what exactly happens is for the PCB board, you need to solder also. So we have something really interesting for that. Please watch the video until the end for the lecture 14. You might learn something practical. And in the lecture 15, we will understand the most beautiful topic, sensors. This is a much more interesting topic to understand. Soon you're holding a few of them and making projects along with me. In the lecture 16, that is introduction to use cases and projects. I'll brief you on the projects we are going to perform practically. You will be getting the components from the ZDAP Technologies delivered. Make sure you have all the components, all of them, before we start the practical sessions. Coming to the lecture 17, 18, 19, 20, 21, 22 and 23, 24, 25. We are going to make practical projects. If you have look in lecture 17, that is project 1, switching the LDR sensor. I'm not going to tell you all the course content of projects, but I'll make sure that you're very good at the hardware part, software part, and you'll also understand how the code works, everything. You will be working on the mediators also. This is the most interesting part. So this is the course content. Let us move to our first session, that is, what is IoT? So everyone knows IoT is something also called as Internet of Things. But what exactly they do? So Internet of Things, they comprises things that have unique identities and are connected to the internet. The Internet of Things refer to the network of connectivity that are the embedded with sensors, software and other technologies with the help of microcontrollers, which help to exchange the data from one to another. The Internet of Things refer to the systems of interrelated internet connected objects that are able to collect and transfer the data over a wireless communication with a human innovation. Personal or business possibilities, they are endless. Okay, a thing can refer to the connected medical device, a biochip. You have much more applications to work under IoT. These all come under a platform called as Internet of Things. All is nothing but you need to transfer the data and actuate from one end to other end. So IoT is not limited to just connecting things to the internet, but also allow things to communicate and exchange the data. So coming to the next characteristics of IoT. The first I want to tell is dynamic and self-configurable. IoT devices and systems may have the capability to dynamically adapt to change their content and also take actions based on their operating conditions. For example, let us take temperature measurement. Let us measure what exactly the atmosphere temperature is. We need to put a sensor. We need to put a monitoring device to monitor the level of the temperature, and we need to observe what conditions they are going. So just observing is one kind of IoT, and observing as well as actuating it is another level of IoT. So we are going to learn everything. Other example I can give is surveillance system. It is adapting itself based on the context and changing conditions. So self-configuring, why I say self-configuring is it allows a large number of devices to work together to provide a certain functionality. Next, interoperable communication protocols. What exactly they do is they support a number of interoperable communications, and they can communicate with devices and also with infrastructure. This happens in machine-to-machine communication. And unique identity. Each IoT devices has a unique identity and a unique identifier IP address. Okay, and integrated. I want to say about this integrated to information network. What exactly that means is that allows them to communicate and exchange the data with other devices and systems. So this is the characteristics of IoT. And yes, Cisco IBSG is really telling something that by 2020 there will be 50 billion devices or things connected to the internet. This is the prediction. But due to the 2020 lockdown, COVID lockdown, you got much more devices connected to the internet. I think the survey will be carrying on by next year or later. You will be letting know how many billions of devices are really connected. I guess I am predicting it is more than 50. So what is your count? Let me know in the chat session. So let us go to the physical design of IoT. So first one, things in IoT. The things in IoT refers, let me open the pointer. The things in IoT refers to IoT devices that have unique identities and perform remote sensing, actuating and monitoring capabilities. IoT device can exchange data with another connected device applications. It collects data from the other devices and processes data either locally or remotely. An IoT device may consist of several interfaces for communication to other devices, both wired and wireless. These include 4 categories: input-output interfaces for sensors, interfaces for interconnectivity, memory and storage interfaces, and audio or video interfaces. Please note down all the 4 characteristics. Okay, so there is no need much description about those 4 categories, but you can just make a note of it. Next one, the second one, IoT protocols. Protocols determine how data is physically sent over the network's physical layer or medium. The local network connects to which it is host is attached. Host on the link, a host on the same link exchange data packets. Data is sent through the packets. It is in the form of packets. It's not the physical packets, but it's just like a packet transferring data from one end to other end. So host on the same link exchange data packets over the link layer using a link layer protocols. You have many protocols. We are going through few protocols of it, which are the important. Even the HTTP hypertext transfer protocol is also a protocol which will transfer the data. You might see in your Google browser HTTP www.google.com. So that is a kind of protocol transferring the data. It transfers the data in the packet in the form of packets. And next one, you have transportation layer. So also I want to say this, in IoT protocols, we have two sessions two categories, a link layer and the network layer. Since I told about link layer, let us discuss a brief about network layer 2. In the network layer, what exactly happens is, responsible for sending IP datagrams from source network to destination network. So it is exactly responsible for sending the datagrams from the source to destination. Datagrams are nothing but your data. The packets of your data is sent in a form of packets from one destination to another destination. That is source destination to source. Sorry. I'm sorry. That is the source network to the destination network. I'm very sorry. So, also next, what type of protocols can I say for you? Can I? Okay. Let me. I hope you all know about the IP. The next one, IoT protocols. IoT protocols are categorized under two categories: link layers and the network or internet layer. Link layer protocol. A protocols determine how data is physically sent over the network's physical layer or medium. Something that a data is transferred in the form of packets. Your data from one network to another network, that is source network to destination network, is transferred in the form of packets. So in the link layer, they find a link host on the they find the link. For example, let us take host and the user. So host and the user will sit under the same link, and they exchange that data in the form of packets. This is what exactly happens in link layer. And when it comes to network layer, it is responsible for sending IP datagrams from source network to destination network. It is nearly the same, but it is in the form of datagrams and it is in the form of packets. Okay. So what protocols can we discuss? Okay, let me tell you that HTTP, hypertext transfer protocol, is also a protocol which will transfer the data under the same link. You can sign in to any page through their http www.xyz.com. So you are going to sign in, that is the host and you are the user. So you're transferring your data by logging in to their website. So this HTTP is one kind of protocol, and you might know about other protocols used in your mobiles: IPv4, IPv6, 6LoWPAN. Okay, I'll be just telling you what exactly they are. IPv4 stands for Internet Protocol version 4. It is used to identify the devices on a network using a hierarchical addressing scheme. That is the type of addressing scheme. Okay, so it allows 32-bit. It is a 32-bit address, which means it allows a 2 into 32-bit address. Okay, so in IPv6, that is Internet Protocol version 6, uses a 128-bit address scheme and allows 2 into 128-bit addresses. Something. All your phones are right now IPv4 or IPv6. Most of them are IPv6. Okay. So next, 6LoWPAN, which means IPv6, Internet Protocol version 6, LoWPAN, over Low Power Wireless Personal Area Network. Please note them down. Low Power Wireless Personal Area Network. This is a kind of operation, and they perform 2.4 gigahertz frequency range and transfer the data of 250 kbps. This is going to be the next feature. And when it comes to the third one, the transportation layer, it provides an end-to-end message transfer capability independent of underlying network. Set up connection with ACK. What exactly should I say about ACK is nothing but ACK as in TCP. TCP is nothing but transmission control protocol, and without this you cannot perform any data transferring. So it provides functions such as error control, segmentation, flow control, and condensation control. So you also call the datagram protocol as well as user datagram protocol. It is also called as UDP, that is user datagram protocol. It is useful in time sensitive applications. What exactly should I say is, in time sensitive applications, what exactly happens is you need to send the data very, very fast. So this can happen with the help of UDP only. So when it comes to the last layer, application layer. So it defines how the application interface with the low layer protocols to send data over the network. And it enables process to process communication using ports. This happens in your normal applications also. So I want to tell you a few protocols. Okay. And okay, this is what the protocols I have told you, the link layer. Okay. This is the first protocol I want to say, HTTP. HTTP is nothing but hypertext transfer protocol that performs the foundation of www. And you can follow request response model, all that you can perform. So under the HTTP you have FTP, SMTP, IMAP, you have all this, but also you need to these all come under that. But when it comes to MQTT, this is a mediator. I want to tell you much more about it in the I guess in 9th session or 10th session. But just note it down, the full form of it, and I'll just explain you what exactly is it. MQTT stands for Message Queue Telemetry Transport. It is a lightweight messaging protocol based on the publish, subscribe, and model. It uses a client-server architecture. It uses a well-suited for the constrained environment. MQTT is something a mediator between you and the device. HTTP is a mediator between you and the software. So that is the difference I could tell. And you have really much more. I have to tell you about UDP and TCP. I told you about IPv4, IPv6, and let us have the quick session of Ethernet, Wi-Fi, GSM, LTE, everything about in the future sessions. And I have told you about the IoT protocols, other one, the network layer, and also the transportation layer, and also the application layer. Okay, let me also tell you what exactly XMPP is, DDC is, and actually DDS it is. Okay, please correct it in your notes. And AMQP. So what exactly stands for XMPP is Extensible Message and Presence Protocol. This is exactly used for the real-time communication and streaming XML data, XML files, right? So these streaming XML data between network entities. Support client server and server communication is possible in XMPP. And when it comes to DDS, Data Distribution Service, it is a data-centric middleware standards for device-to-device or machine-to-machine communication. It uses a publish-subscribe model. It is the same type of model for everything. Application layer always uses a publish server model or service-to-service communication. And when it comes to AMQP, this is all important for your quiz. If you have a quiz or if you have any exams related to IoT, they ask you the where is the publish server subscribe model, or else server to server communication models are used. You can just simply mark it that application layer uses it, and all the applications layers like HTTP, COAP, MQTT, XMPP, all these uses service to service communication. And COAP stands for Constrained Application Protocol for Machine to Machine Communication. M2M communication deals with much more communication layers. That is the reason that doesn't need human interface only. And AMQP stands for Advanced Messaging Queuing Protocol. It is an open application layer protocol for business messaging. So it supports both point-to-point and publish-subscribe model. So also it has service-to-service communication. So Yeah, I have all the abbreviations here. You can just pause and you can just note it down. And what are the advantages of IoT? I hope you have cleared at least a 10% or 15% of what exactly IoT means rather than other people. Other people just know what exactly is IoT is. It is connected to the internet and transfer the data. But how is it going to transfer? And how are you going to perform that? How are you writing the code for it? How are you implementing the devices? Everything is a part of IoT. So coming to advantages point, let us see the first advantage, that is security. IoT has a separate API key. I'll discuss about the API keys very soon. So it is much more secure. No one can really hack your or else no one can just peep into your devices. And next one, IoT is day-to-day advancement. Yes, it is true. And it is growth in communicating devices. As I told, Cisco also already predicted that 50 billion devices might be in 2050, 2020, but I am expecting much more than that. And the analytics part, when it comes to analytics part, IoT is much more advanced in it, much more higher in the analytics chart. So IoT is also money saving. Once if you implement an LED light, you get the current bill in the lower range than usual. So that is the same principle used in IoT also. Let us say that you have a home automation in a home, which is one-time implementation, and later you can easily access through your home from anywhere in the world. You can just switch off the light by using the voice command or Blink app, and you can just say them to switch off the light, and it automatically switches it off. So it is really money saving or also time saving. And it is encrypted communication. It end-to-end encrypted, so no one can really access your data. So in 2015 the IoT usage was 30%. That was only in the IITs and in MS fields, I guess. But later it was implemented in every sector. And when it comes to AI and ML, that is artificial intelligence and machine learning, it was only 10%. But I guess in 2019 that is up to 35%. But in 2020 I feel that is more, because much more workshops are carrying on in the world. And IoT is 60% in 2019. That was the greatest evolution, from 30% to 60%. So what exactly happened to wired communication? 60% to 5%. When the codes are in advance, the wire-to-wire communication became less. So wireless communication. Okay, sorry, here this is a wireless communication. Maybe I have typed it wrong. Sorry for that. So wireless communication have become 5%. I can't say 5%, but it might be really when it comes to the IoT or AI ML compared to this comes under 5% only, I feel. So world is IoT, isn't it? Yes, world is IoT. World is moving to IoT. So your data will be safe. I will show you how the data centers look like, how are your data stored, and how secure your data is also. Okay. Today the world is experiencing the wireless data transmission. Servers are busy storing your data safe. True. So any doubts about any lecture session or future lecture sessions also, please let me know in the chat session, or you can also email me at krishnazeedup@gmail.com. That is krishnazeedup@gmail.com. I repeat, krishnazeedup@gmail.com. I will respond to you immediately. Let us move forward to next session. Thank you. In this lecture, we will understand how does IoT work. So, a complete IoT system integrates 4 distinct components: sensor devices, connectivity, data processing, and a user interface. Below, I'll be briefly explaining each component and what it does. Let us learn it in an interesting way. Let us say talk to the device. IoT system consists of a sensor devices which talk to device or talk to the cloud. Cloud is something which stores the data and transmit the data. So it talks to the cloud through some kind of connectivity. Once the data gets to the cloud, software process it and then might decide to perform action, such as it can perform any action such as sending an alert or automatically adjust the sensor devices without the need of the user. So there should not be any need of the user, which means no need of human interference. So you no need to actuate anything. The data and the cloud, the data in the cloud can access all your actions and perform the same. So, but if the user input is needed, if the user simply wants to check on the system, a user interface allows them to do so. So that is the reason I told user interface is a fourth common distinct components. So any adjustment or actions that user makes or then sent in the opposite direction through the system, which can interact with the device and get the data from the device. So user interface is nothing but getting the device in form of data or else in the form of actions. So let me say about first sensors. I want to just briefly discuss about the sensors part. So first, sensors or devices collect data from the environment. I'll just tell you what exactly the process is. Okay. First, sensors or devices collect data from their environment. Their environment can be anything suitable for them. For example, let us say a PIR motion detector sensor. This environment is that it accepts any movement in the any movement in the range of 10 centimeters to the sensor. So this is their environment. Environment is independent for their sensors. Okay. So this could be as simple as a temperature reading or a complex as a full video feed also. I use sensors devices because multiple sensors can be bundled together, or sensors can be part of a device that does more than just sense things. For example, your phone is a device that has multiple sensors: camera, accelerometer, gyroscope, GPS. But your phone is not just a sensor, right? So this is what exactly happens. However, whether it is a standalone sensor or a full device, in the first step, data is being connected from the environment by something. So when it comes to connectivity, so this is all about the sensors. Next, the connectivity. Connectivity is something much more important. So the data is sent to the cloud, but it needs to way to get there. The sensor devices can be connected to the cloud through a variety of methods, including cellular, satellite, Wi-Fi, Bluetooth, or else also I told you low power wide area networks, or LPWAN. This is also called as like low power wide area networks. This is the near future, and they directly connect to our internet via Ethernet also. So connectivity can be any type, but the ultimate thing is the data should be transferred from one form to other form. So I want to just let you know why this is actually the skipping the connectivity. Okay, we should skip the connectivity. Why to skip the connectivity? What is a connectivity mean? I told you before that transferring the data from one form to another form with the medium, not the mediator, with the medium. The medium can be Wi-Fi, Ethernet, cellular, Wi-Fi, LPWAN, and any type of source. So there should be a medium that data should be transferred. So I need to skip the connectivity. Why? One reason is latency. Latency refers to how long it takes for a packet of a data to get from the start point to the end point. Although latency does not matter in the vast majority of cases, for some IoT applications, latency is critical. Imagine you are in a self-driving car and suddenly somebody loses control of the car in front of you. Would you want to wait for the self-driving car to send back to the cloud, have the data process? So you have seen this MG Hector car, right? So that maintains the relative velocity of the car in the front. Based on the front car. Let us say the car A is moving in the speed of 50 kilometers per hour, and your car, which is an MG Hector car, is moving at the speed of 50 kilometers per hour. This is because there is an IoT sensor which calculates the speed of opposite vehicle, and then it limits your speed. So this is what happens. This is the latest technology. There are great minds out there for reaching they want their great minds to be propagated and to be implemented in several industries. If you have a really idea, don't be late, be quick and reach them out. So why to skip the connectivities? The first reason is latency. Okay. Another reason is that sending lots of data can become really expensive. Some IoT applications collect a ton of data, but only a small fraction is actually important. Local algorithms can restrict what gets sent, thus lowering cost. Exactly right. A good example is a security camera. Streaming video takes a lot of data, but the vast majority of the footage might be on an empty hall away. Isn't it right? Just to watch one robber. Just to watch out one robber, we equip a big material of CCTV to your building. So this collects much more data for plain wall, but only one instance we put a bulk instruments. So how do we skip the connectivity? The third point, let me put the pointer. Yeah, how do we skip the connectivity? So rather than send the data over a network for it to be processed in the cloud, all of you might have this doubt. When there is no medium, how to send the data? But right now, I'll be explaining about the fog computing and edge computing. This is how you can skip the connectivity. So rather than sending the data over a network for it to be processed in the cloud, an alternative approach is to be process the data on the gateway. What's the gateway? Or what's the gateway? You might ask. The word itself defines the other form of medium to transfer the data from one network to other network, that is source network to destination network, in the form of fog computing or edge computing. So this is called their fog computing and edge computing. So in this, what exactly happens is, in the fog computing and edge computing, you can really make a own network. See, you're bringing cloud closer to the ground, and the computing is taking place at the edges of the IoT system rather than the center. For the security camera, it could use a mission vision to watch for anything abnormal and only then send the footage to the cloud. Yes, right. And when it comes to a self-driving car, the data processing all takes place in the onboard computer, which allows for faster decision making. So you can make use of fog computing and edge computing. What exactly happens in fog computing and edge computing is, this is the cloud layer. This is the cloud layer which access all your data. Okay, if you are the user, your input is sent to the application, and this application, with the help of the fog server, your application layer is nothing but the edge layer. See, your application layer can be large volume real-time data processing. Okay, once your application reaches your input, this application sends the data to the fog layer. This is a server. This could be any protocol. This could be any type of protocol. It is just like your Wi-Fi. Okay, and this fog protocol is then sent to the cloud. Your cloud handles all your data. Okay, this is the data warehouse. Okay, and this cloud can again send back to the fog server, and then again back to the application, and then again back to the user. So user can access the data and also send the data. So this is what exactly happens in fog computing and edge computing. This is the fastest and reliable method in the coming days. I'm sure this is going to be implemented very soon. Okay, and also I want to tell you about the IoT complex and variables. Every IoT system combines the four components. Sensor devices, as I discussed in the part 1, connectivity, data processing and user interface. However, as you have seen in this IoT, in this part, a specific IoT system can combine these components in different ways. It all comes down to the specific situation that needs to be addressed. Ultimately, IoT systems are meant to prevent our everyday expenses and improve our efficiency in whatever way possible. And now you know how an IoT system actually works. So I'm happy for it. And coming to the advantages or disadvantages, I want to just tell you what exactly is a security mean. Your security can be not just two-step verification or not just like WhatsApp and all. Your security is much more secure than anything. IoT security is the most high secured data files. It is just you don't even imagine, or you don't even expect the same thing. How can my security be dependent on the Wi-Fi or database? If someone hacks, what exactly happens? Your data might be lost, but your other data might be lost, but in the data stored through IoT will never be lost. And I also want to tell about the actuator, since we have bought the sensors part also. Actuator parts is nothing but which converts electric signal to the physical signal or any mechanical signal. Usually an electric signal is transmitted as the physical signal. So this is an example of linear actuator. What exactly happens in linear actuator is, linear actuator, you can see this in the hydraulic brake stations or JBS or also pulleys. In these kind of machines, you can see these linear actuators. They scroll down, or the rod comes down. Again, it goes back. This movement is called as actuation. This is sent through an NAD data processing. We will make a project with that also, but in the advanced level, not in the this level. Okay, we have much more projects to do. We will use any type of solenoid, or else relays will be using in this level only, and also linear actuators. We will go through all these actuators and transducers very soon. Motors and relays are going to be used in this level only. Solenoids and linear actuators we'll be using it in the advanced level. So next, the future, I could say that it is a limitless, obviously. So future of IoT is limitless and it is incredible. So, and also it is advancement in industrial internet, because Internet of Things handles with the internet, or else it can be fog computing and edge computing also, they go to the internet. So you need to know that fog computing and edge computing is also transmitting data via internet only. But ultimately, see, Ethernet also transfers via internet, Wi-Fi transfers via internet, everything transfers via internet. But what exactly happens is latency between fog computing or edge computing and the other networks like cellular, Wi-Fi and other things. So that is a difference. So advancement in industrial internet is much more. And integration with AI and ML. Everyone might be heard about this as of now. Everyone are integrating with AI and ML. And you can automate. Yes, automation also will be taught in the home automation. You can just tell, okay Google, turn on the light in your home in the next level. Okay. So orchestrate. You can really improve all your IoTs very soon, I'm telling you. And I want to tell this also. Till up to now, you might be clear of how exactly IoT works. But I want to also tell you that how IoT works on these 5 stages also. First, what exactly we learned is the same thing we are going to tell now. Like whatever we have covered up to this, the same thing is taught in the 5 stages. The stage 1 is fetching the data. That is getting the data from any medium, from any source, and decoding the data in the form of binary or else logic gates. Using the logic gates, you get in the binary form, because computer accepts only binary languages. And next, stage 3, execute. When the user gives any input, it executes. And stage 4, it is only few microprocessor only take up to 3 stages only. But since IoT uses much more bigger microcontrollers or advanced microcontrollers, they have 5 to 6 stages. Okay, the stage 4 is memory access. They can access your memory, because when you need any type of data, you can get back or you can fetch from the memory. That is a cloud storage. And next, stage 5, that is write back or register back. That is nothing but you can overwrite, or else you can edit them and you can send back to the cloud. So this is what exactly happens in IoT stages. I hope you're clear with it. And IoT looks like a puzzle. Really? I don't feel that. If you learn it in a proper way, then it is not. So, but no, yes, it is not. So, any queries about any lecture session, please let me know in the chat session, or you can also email me at krishnazdup@gmail.com. I will respond you immediately. So, let us move forward to the next session. Thank you. Hey, hello. Welcome back to another lecture on our course IoT. This course is brought to you by ZDAP Technologies. In this lecture, we will understand the components of IoT. So, what are the key components? IoT is not just transforming connectivity among devices and objects, but it also allows people to get remote access easily. With so many advantages of IoT, it is interesting to see the main ecosystem components that IoT works on. Here are the main components on which IoT works. Let me open the pointer. That might be a gateway, a thing, or see what exactly happens. I'll just explain you the flow chart of this. This is the device. This is the device, and this is the user interface. To transmit the data from this end to this end, there is a small process. The data should be transferred. So the user interface is first sent to the cloud, but in the form of analytics. So why analytics in between is that the analytics is something which analyze your data. How it is exactly just like a data sheet of your sensor. Okay, this tells how much size your data is, how many packets does it require, and everything. This analytics analyzes the data and the quantity of your data, and then adjust your separate database for you and put it in the cloud. And this cloud will send to the gateway, that is the the device gateway. This gateway is nothing but like it might be anything like an electronic signal. So this cloud is sent to the gateway, and this gateway is sent to the device. Okay, this can be transferred from the gateway to the device, can be transmitted in the form of wireless or wired. But ultimately the data has to be transferred from the gateway to device through the cloud only. So what exactly happens here is there is a size limit for you. What exactly I want to say is there's no size limit, but there is a space for you. It is in the cloud. There is space kept separate for you. So in this analytics will analyze your data. How much space is it required for you to put your data in the cloud? How much space to be stored in the cloud? Everything it analyzes, and then it stores in the cloud, and then the cloud sends to the gateway and then to the device. So this is what happens in the components of IoT. So the first one I want to tell about is major thing is gateway. The gateway enables easy management of data transferring flowing between protocols and network. See, I am discussing about wireless communication only, because wired communication is nothing but simply putting an electronic signal, analog signal, transferring the analog signal and changing it to a digital signal using ADC converters. But I don't want to make it much lag or something. So that's why I want to discuss about the direct wireless communication. The gateway enables easy management, as I told before. On the other hand, it also translates the network protocols and makes sure that the devices and sensors are connected properly. It can also work to pre-process the data from sensors and send them off to the next level if it is configured accordingly. Okay, note that it is essential to configure it as the presence of TCP or IP protocol, internet protocol, as I said. So it allows easy flow. Okay, so not only this, it gives you proper encryption with the network flow and data transmission. The data flow through this, it is in the higher order, that is protected by using the latest encryption techniques. So you can assume it like an extra layer between the cloud and device that filter away the attacks and illegal network access. So this increases your security. I feel that. So I told you about the device, but let me explain you in the form of every example here. Proximity detection. Proximity detection is used in your lift doors. That, for example, you are going to enter into the lift and automatically your door expands. This is because of the proximity. So this proximity sensor. What exactly it does is it tells to the lift not exactly the lift operator, but lift operating system. The lift operating system is whatever it is there. The sensor sends a sensor bit of data that someone is coming, please expand the door. This sensor will allow, this actuator will allow to expand the data when the sensor senses any type of proximity. So Here I explained you the type of the user, that is nothing but the operation, and the thing, that is nothing but our two things are there. One is a sensor and one is our actuator. So to expand the gates, one is actuator, and to sense the device, to sense the motion, a sensing device is used, the proximity device, the proximity sensor. So you can also have this type of sensors like USB sensors or normal sensors, but we'll be going through all of them, all the types of sensors very soon. And next, let me come to the humidity or moisture level. What exactly happens in this is, in humidity or moisture level sensor, there is a moisture level sensor that can access the atmosphere temperature and tell you in the digital form or else in the serial monitor form what exactly the data is. So these I don't want to take a lag of humidity or temperature sensors, because already I told you before and you might be clear about it. I'll be letting you know about the RFID tags, because that is the most important thing. You might have seen the metro cards, or right now you're getting the fast tags near the toll gates. So this is because of the RFID. So this works on near field communication, NFC. There is a RFID tag which is nothing but it scans your data in the form of a card, and it can access the data in the only by detecting or else by accepting. Detecting in the form of, it can be in the form of money, or else it can be form of data, anything. So it just detects and accepts. That is the duty of the RFID. You cannot make anything much more than that. So that is why RFID are most accessed, also called as which cannot be hacked. ATM cards cannot be hacked directly. They need to be hacked by multiple process. So that is why we tell that RFID tags are much more secured. That is the reason we have bought it till here. The ATM cards and all are bought it till here in this level 2020 also. This is because of that technology only. So I just told you about the gateway, cloud, and analytics. Yes, and let me go to the user interface. Analytics, I hope you all have understood that. And user interface, yes, we have gone through that also, but I just want to tell you that user interface is really friendly, because that is the kind of device you're operating, and it could be formal also. Because there are few mediators that act as a formal, because if you don't want to create your own app, or if you don't want to make your own data center, then you can also use the mediators, which is in the formal type. And authentication is very hard. Authentication is very simple only for you when you have the API keys and all. So, and analytical way, it is very good, and the transferring of data is very quick because of the today's technology. And that is actually actuating. I have small spelling mistake there. And signal passing, I just told you signal passing and actuating is altogether done at one single step only. The next one is database. Internet of Things is increasing dynamically and is all dependent on the data that are used immensely in the data centers. It is essential to have a proper database that system that can store and manage the data that is being gathered from various devices and end users. There are also various management tools that offers many automated features that help in the easy accumulation of data stored and managed in bulk at the same place. I want to show you the something really important. I'll just one second. Google database. You know how that does look. Let me open Google Database Center. Okay, sorry. So this is how the data centers look alike. Let me open few of them, others also. Okay, let us have a 360 degrees view. Worst website was open. Okay, this is something video, but I don't want to show the video, please. the Google data center is quite good. Let me show you just like this. Your data is stored in this type of data, in this type of hardware. Okay, so no one can hack your data. And once your data, for example, let us say this hardware is spoiled, this hardware is again never used. Okay, you know that there is a crusher in the Google data center itself. In any data center there are crushers, so they crush they crush and they break the hardware part, and such that it is never again used, so no one can access your data. Now you might wonder that your data might be lost. No, your data is in the form, they are replaced in the form of other hardware, but your data is never lost. That is the reason cloud storages are always reliable. They need the much cooling system. In the always the copper cooling is always done for every data center. That much of amount of heat is produced outside, and also radiation is produced outside. No one can imagine even. So let me just move back to our session. I hope you're clear with data centers and databases. And next, let me come to the automation part. As I mentioned, the database is using the automative feature that help in managing data and accumulating. However, data management is the only limited thing that is used by Internet of Things. It is now used for much more advanced version that allows the automatic adjustment of wireless things. For example, you can easily control light with a click of the remote or with an assistant. The air conditioner is now connected to your smartphone, and now you can switch them on and off whenever you want. Even it is possible to play with the temperature, isn't it? So, but where is IoT used? If you ask me where exactly is IoT used, the automation itself is an IoT. And the development. Internet of Things is the latest advancement in technology. The need for the development is growing and increasing with time. Each and everyone is not dependent on the launch of various automated devices, smart sensors. So you need to make one new, right? So you can't depend on always on for several platforms. There are various prototypes that are in the market that are being deployed and are running in the testing phase. Also, IoT is not only working with only one device but also many. Hence, it is important that the devices are completed test accordingly to the compatible of the device and to the compatibility of the user also. So we have managed to experience many things and advancement in most of the technology. IoT ecosystems is used to make the protocols easily accessible, reasonably priced, efficient, and it is secure. It will be exciting to see the new demands and development in the several sectors that will be bought by the Internet of Things. Especially the way it connects different companies and vendors together. I like that personally. The main thing is that we need to look out for the way everyone can incorporate this ecosystem to increase their production, isn't it? So thank you. This is the end of session. Any doubts about any lecture session, please let me know in the chat box, or else you can also email me at krishnazdup@gmail.com. I will respond to you immediately. So that's it. Let us move forward to the next section. Thank you. Hey, hello. Welcome back to another lecture on our course IoT. This course is brought to you by ZDUP Technologies. In this lecture, we will understand the applications and careers in IoT. So, you all might be wondering what are the careers in IoT, but I'm going to make it clear for you. So first I want to say about the domain specifics of IoT, okay? The applications of IoT. First one is home automation and cities. Let me tell you about home automation first. Home automation, let us take an example of smart street light. It helps in saving energy by adapting the light to the ambient conditions and switching on or off or dimming the light when needed. So we are going to make this project very soon. And that is the first project of our practical sessions. And the smart appliances, the second one, makes management easier and also provides status information to the user remotely. When it comes to intruder detection system, it uses security cameras and sensors, like for example PIR sensors. We are going to make that project also. Please make a note of it. So this is to detect intruder and raise alerts. Alerts can be in the form of SMS or email sent to the user. So also next can be the smoke or gas detectors. Smoke detectors are installed in the homes and buildings to detect smoke that is typically an early sign of fire. Alerts raised by smoke detectors can be in the form of signals to fire and alarm system, and or else police alarm systems. Okay, any kind of alarm systems. Gas detectors can detect the presence of harmful gases such as CO or LPG gas detectors. Okay, and when it comes to cities part, I want to mention this: smart parking. IoT is a major application for this cities, like smart parking. It make the search for parking space easier and convenient for drivers. Smart parking is powered by IoT system that detects that number of parking slots are empty and send the information over the internet to smart application backend, sorry. And next, the smart lighting, under the cities only. Let me say about smart lighting. It is for roads, parks, and buildings, can help in saving the energy. It is just like dimming the light when needed. So next one, smart roads. It is equipped with roads are equipped with sensors. You might wonder it how, but it is possible. Transistors are placed under the tar roads. Okay, this is done in various countries also. The roads are equipped with the sensor that can provide information on driving conditions, travel time estimates, and alert in case of poor driving conditions, or else alert in case of any type of holes or potholes, etc. And structural health monitoring system can be equipped in the cities. For the city people. So it uses a network of sensors to monitor the vibration levels in the structures such as bridges and buildings. And surveillance, of course, in IoT is a major platform for surveillance, as I told before, and also in emergency response. IoT systems for fire detection, gas and water leak detection can help in generating alerts and minimizing their effects on the critical infrastructures. Okay, so let me move to the environment and energy. So when it comes to environment, let me explain about weather monitoring systems. These systems collect the data from number of sensors attached, and then they send the data to cloud-based applications and storage backends. So the data collected in the cloud can then be analyzed and visualized by the cloud applications. Air pollution monitoring system can also be another type of application under environment. The system can monitor the emission of harmful gases like carbon dioxide, CO2, CO, and NO2, etc. by factory. These are polluted airs by factories and automobiles. So this can be analyzed and this can be monitored by various sensors by using this application, and also alerting the required officials with the help of these sensors. And noise pollution monitoring. Due to growing urban development, noise level in the cities have been increased and even become alarmingly high in some cities. IoT based noise pollution, even you might be hearing right now some traffic sound. This is because much more urban. What exactly happened is population has been increased, and also the number of usage of vehicles has also been increased. So to control that, we don't find a particular solution, but to monitor and you can just aware them by monitoring them. So this is what we can do as of now. If you have really quick ideas, don't waste your time and just quickly go to the required officials and alert them. So next one is forest fire detection. Forest fire can also cause damage to natural resources, properties, and human life. You might have heard about the Amazon fires and Australian fires also. But what if the case was like before? We might know that fire has been started way long before. Okay, we might get the notification before itself. Then we might get alerted before itself, right? The forest department will be really satisfied with the news, and immediately they might take an action. So for preventing that kind of other kind of emergencies, we need to put a forest fire detection systems, and also just like that we can put river flood detection, sorry. Okay, river floods can cause damage to natural and human resources and human life. Early warnings of floods can be given by monitoring the water level and flow rate. This is happening right now. Okay, this is a good step by the governments. And when it comes to energy, Smart grids. Smart grids is a data communication network integrated with the electrical grids that collect and analyze the data captured in real time about power transmission, distribution, and consumption. You can put a power monitoring device at your home. I mean, there is a power monitoring device, but in the form of money, because you can adjust your money. I mean, you can adjust the rate per unit. It is approximately, let us say, if you're 7 rupees per unit, okay, then you can estimate the how many number of units you are using, and it automatically displays you the amount of, approximate estimated amount of the price you have to pay to the electricity. So this could be implemented in your home itself. Go try it out. And next one is renewable energy systems. Okay, so and you got much more in retail and logistics. What exactly happens in retail and logistics is you will know whether the mall, whether the store is empty or not. I mean, whether it is full of customers, or we can just go in the engaging part itself. So this has been implementing in several countries. So also there are smart vending machines in the malls. Sensors in smart vending machines monitors it operates and sends the data to the cloud, which can be used for predictive maintenance. Smart payments solutions each by NFC method itself, or else UPI payments, you might have heard about it. And also solutions such as contactless payments provided by technology such as near field communications and Bluetooth. And IoT systems enable real-time monitoring on remote monitoring of inventory using data collected by RFID readers. I told you RFID is much more secured. And when it comes to logistics, I want to also mention about logistics that route generation and scheduling, that is IoT based system backed by the cloud, can provide the first response to route generation queries and can be scaled to a large transportation network. Okay, and shipment monitoring. IoT based shipment monitoring system uses sensors such as temperature, humidity to monitor the conditions and send data to the cloud, where it can be analyzed to detect the food spoilage. And remote vehicle diagnostics. Systems uses onboard IoT device for collecting data on vehicle operations and the status of the various vehicle subsystems. Okay, and next, when it comes to the industries, I also want to mention about the agriculture also. But see, agriculture, we can mention about the greenhouse control and the smart irrigation. We are going to make the smart irrigation project very soon to determine the moisture control amount in the soil and watering the plants. And greenhouse control is to improve the productivity. Okay, and next comes the industry. Mission diagnosis and prognosis, we can say about the industry. And the indoor air quality monitoring is much more important in industries, because people working out there are much more exposed to the harmful gases. We should get rid of it, right? So we can just monitor by the indoor air quality. And next comes the health and lifestyle. For example, we can say health and fitness monitoring. You have much more devices for it. Oximeters, you have pulse monitoring devices, and wearable electronics. It can calculate your vital body parameters, just like your fever, etc. And your medication equipment and wheelchair also. Wheelchairs, how automated wheelchairs are now available in the market. So coming to the most important part of our this lecture, careers in IoT. What are the different types of IoT jobs and job roles? I want to mention each of them available here. Each of them shown here. Millions of jobs are waiting for the talented and skillful people in the era of IoT. There are different jobs roles offered by the IoT industries. Let us have a quick look at where you can fit in the best. So the first one is cloud engineer. It is one of the job roles where a person needs to establish and deploy the middleware and NoSQL database to collect the data from the IoT device. I'll be explaining about the cloud engineer of MySQL and SQL also. MySQL, NoSQL, SQL. I'll be explaining about all the query languages very soon. But I'm not going to be a tutor for the. I'm not going to teach the code for it. I'm just going to tell you what exactly they are. Because MySQL, I'm not going to concentrate on the jobs session. I'm going to just tell you what exactly these jobs, what exactly IoT are offering jobs. Okay, and the designer, CAD designers, you know about the CAD, AutoCAD, I mean 3D printings can help the IoT industry to better design the device such as wearables. And next one is material specialist. People with this job are good at understanding and finding which material should be used that can embed a sensor in it. So embedded engineer, these engineers are responsible for developing and implementing a software that of the embedded devices. And network engineering, those who help in establishing a computing network or choosing a suitable gateway, and much more. You can consider a network engineer. You know, node networks, transmission networks, everything could be possible. And data scientist, they help in analyzing the collected data using in memory computing or batch processing and converting into useful information. And data visualization network, that is the task of these profiles is to present the information in visual manner to maintain it more understandable. UI engineering, which means the user interface engineering, these people are helping designing the easy and interactive user interface for the IoT devices. The data architect, those who are those who design the data module, that is for the data architect. And instrumentation engineer, okay, I don't want to scroll it more because this dialog box is getting appeared. Instrumentation engineer, they are responsible for handling actuators, sensors for the closed loop system. Test engineers, who test the functional aspects of IoT devices. And the last one, the programmers, who programs the backend and they integrate it with the middleware and cloud database. Don't you feel that programmers are everywhere? Sometimes I get angry too, but that's fine. So you have other jobs also, PCB designing and manufacturing. You know, you can print your PCB boards. And signal conditionings, you know, the the signal source should be amplified and then should be converted to digital in the form of binary bits and then to be displayed in the application software. This is just the flow of what exactly I explained. And the software in IoT, Python is the major platform for the IoT. You can just write much bigger codes using Python for the sake of IoT. And I told you about the medical and health. You can also make, you know, dialysis instruments are made by instrumentation engineers only. So there is a much scope in medical and health department also. So any doubts about any lecture session, please let me know in the chat session, or you can also email me at krishnazdup@gmail.com. I will respond to you immediately. So let us move forward for the next session. Thank you.